SpaceX just achieved what aerospace giants spent decades failing to crack: orbital refueling at operational scale. NASA theorized it, China tested it, but Musk's team actually made it work. This single breakthrough is reshaping the entire space industry economics. So why does this matter so much that it could justify an $800 billion company valuation? And what does perfecting this technology really mean for Mars missions? Let's dive right in. Here's the thing most financial analysts missed when those $800 billion valuation reports hit the headlines. Elon Musk had to step in personally to correct the record. SpaceX isn't desperately hunting for new investors or burning through cash. The company is conducting routine stock buybacks, providing liquidity to employees and early investors who've been along for this wild ride. Why does this matter? Because it reveals something extraordinary. SpaceX has been cash flow positive for years now, generating more money than it spends, which almost no rocket company in history has achieved. But here's where the story gets interesting. Musk also addressed something critics love to throw around. They claim SpaceX only succeeded because of NASA handouts and government subsidies. The reality? NASA contracts will represent less than 5% of SpaceX revenue next year, and those contracts weren't gifts. SpaceX won them by delivering the best product at the lowest price, beating out aerospace giants with decades of experience. So if government money isn't the secret sauce, what actually powers this money-printing machine? The answer is sitting 330 miles above your head right now. Starlink has become the most underestimated business empire of the 21st century. Traditional satellite internet providers like HughesNet operate from geostationary orbit, roughly 22,000 miles up. Your signal has to travel all that distance twice, creating latency between 300 and 1,000 milliseconds. That's a full second delay every time you click something. Starlink satellites orbit at just 330 miles altitude, slashing that latency to 20 to 50 milliseconds, with download speeds regularly exceeding 100 megabits per second. For millions living in rural areas where cable companies refuse to build infrastructure, this isn't just faster internet. It's the only real internet they can get. The scale is staggering. SpaceX has already deployed over 8,000 satellites and serves more than 8 million subscribers worldwide. Amazon's Project Kuiper, supposedly the big challenger, hasn't even started commercial service yet. But Starlink isn't just connecting farms and remote cabins. The U.S. Space Force is now contracting SpaceX to build MilNet, a highly secure military communication network that's nearly impossible to jam or intercept. Advanced beamforming technology, massive bandwidth, ultra-low latency, all packaged in a system that proved absolutely critical during the Ukraine conflict. When traditional communications went down, Starlink kept Ukrainian forces connected. How much is that strategic military capability worth? Here's the beautiful part about Starlink's business model. It's brutally simple. They charge customers more than it costs to provide the service, creating consistent profit margins that compound month after month. That steady cash flow allows aggressive expansion while maintaining financial health. But this revenue stream didn't appear by accident. It was built on top of a revolution SpaceX quietly achieved while everyone else was laughing at them. Reusable rockets. When Elon Musk first proposed landing orbital-class boosters and flying them again, aerospace executives literally mocked the idea. They said it was physics fiction, economically impossible, engineering fantasy. Traditional rocket companies like ULA built their entire business around disposable rockets. Launch once, throw everything away, build another one. That's like buying a new 747 for every single flight from New York to London, then pushing it into the ocean when you land. Insane, right? Yet that's exactly how the rocket industry operated for 60 years. SpaceX bet everything on a different approach. The Falcon 9 started landing boosters in 2015, and something remarkable happened. Each booster could fly again, and again. Some Falcon 9 boosters have now flown over 20 missions. The cost per kilogram to orbit dropped by roughly 10 times compared to early Falcon versions. Engineers started calling this the SpaceX curve, where each iteration dramatically improved capability while slashing costs. Today, Falcon 9 can carry more than twice the payload of its original design while costing a fraction to operate. SpaceX has now surpassed 600 total launches. In 2024 alone, Falcon rockets carried approximately 80% of all mass launched into orbit globally. Think about that. One company, one rocket family, delivering more to space than Russia, China, Europe, and every other competitor combined. The U.S. Air Force just approved increasing launch cadence at Vandenberg to 100 Falcon missions per year. They also greenlit Falcon Heavy operations from the same site, meaning California will soon see those massive triple booster rockets launching regularly. What happens when one company achieves this kind of operational dominance? Traditional aerospace giants are crumbling. ULA, once the unquestioned king of American rocketry, is reportedly facing serious financial trouble, possibly even bankruptcy. They mocked reusability. Now they're desperately trying to copy it, years behind, bleeding money on every launch. Meanwhile, SpaceX is reinvesting Falcon profits into something that makes reusable boosters look like baby steps. Starship. This isn't just a bigger rocket. It's a complete paradigm shift. Falcon 9 is partially reusable. You recover the booster, but the upper stage burns up. Starship is designed for full reusability, both stages landing and flying again within hours. The target performance is mind-bending. Between 100 and 200 tons to low Earth orbit for an estimated $2 to $3 million per flight. Let that sink in. That's more than 10 times cheaper per kilogram than Falcon 9, while supporting dozens of reuses per year. At those economics, things that seemed impossible suddenly become routine. NASA's Artemis lunar lander, that's Starship. Mars colonization, Starship. Point-to-point Earth travel, where you fly from New York to Tokyo in 45 minutes? Also Starship. But none of those missions work without solving one critical problem that stumped the entire aerospace industry for decades. Orbital refueling. Here's why it matters. If you load Starship with enough fuel to reach the Moon or Mars, you can barely carry any cargo because the fuel weighs too much. But what if you could launch the spacecraft with just enough fuel to reach orbit, then send up multiple tanker Starships to refuel it in space? Suddenly you've got a fully fueled vehicle with maximum payload capacity ready for deep space missions. This is the breakthrough that unlocks everything. NASA theorized it, China tested small-scale demonstrations, but nobody has achieved operational orbital refueling with cryogenic propellants at the scale Starship requires. SpaceX is building it right now. The technical challenges are brutal. You're dealing with super cold liquid oxygen and methane in zero gravity, transferred between two spacecraft moving at 17,000 miles per hour. The slightest leak, the smallest alignment error, and you've got catastrophic problems. Many of the technologies involved, like the fully reusable heat shield and autonomous orbital docking systems, have never been proven at this scale. Developing this requires enormous capital, years of testing, and accepting expensive failures along the way. Which brings us back to Starlink. That profitable satellite internet service reportedly went cash flow positive 2 years ago and continues growing explosively. Its massive subscriber base generates recurring revenue that's now funding Starship development. In other words, Starlink pays for Mars, but the relationship works both ways. Once Starship becomes operational, it supercharges Starlink's expansion. A single Starship launch can deploy 60 Starlink V3 satellites, each with over 1 terabit per second downlink capacity, adding 60 terabits per second to the network. Compare that to Falcon 9, which currently carries about 28 to 30 V2 mini satellites at roughly 100 gigabits per second each, yielding only 3 terabits total. Starship delivers 20 times more network capacity per launch than Falcon 9. This creates a self-reinforcing loop. Starlink generates billions in revenue that funds Starship development. Starship slashes deployment costs that make Starlink more profitable. More profits accelerate Starship iterations that unlock Mars missions, orbital manufacturing, and space tourism. Each piece amplifies the others, creating exponential growth that traditional aerospace companies can't match. With projections targeting over 24 Starship launches per day at peak capacity within the next 6 to 7 years, we're talking about fundamentally reshaping both the launch industry and global telecommunications simultaneously. Is this why investors value SpaceX at levels that make traditional companies look like rounding errors? Now here's where we need to address the elephant in the room. Could SpaceX have built all this completely alone, with zero government support? Absolutely not. Just like every rocket company in history, SpaceX stood on decades of publicly funded research, technology development, and trained expertise from NASA and other government programs. NASA spends roughly $25 billion yearly on research and development. That R&D produces public domain knowledge, engineering breakthroughs, and graduates thousands of aerospace engineers that private companies can hire. Since 2006, SpaceX has received over $15 billion in government contracts, including $4 billion for commercial crew and $2.9 billion for the Artemis human landing system. NASA's Delta Clipper program in the 1990s explored vertical takeoff and landing, composite fuel tanks, and aerospike engines on modest $60 million budgets. Those public domain experiments directly inspired SpaceX's Grasshopper tests in 2012 to 2013 and the Falcon 9 booster landings that followed. Many engineers from those early NASA projects later joined SpaceX and Blue Origin, bringing invaluable experience that taxpayers had effectively already invested in developing. Without that foundation, the training, the data, the proof of concept, building SpaceX from scratch might have been financially impossible for any private startup. But let's be completely fair about what actually happened. The early NASA funding SpaceX received wasn't charity or blank checks. It was part of programs like Commercial Orbital Transportation Services, where NASA paid approximately $396 million for cargo delivery to the ISS. SpaceX had to meet specific milestones and deliver actual services at prices far below traditional aerospace providers. More importantly, they're currently the only option that passes NASA's rigorous human safety standards for crew transport. It was a legitimate win-win partnership. NASA got cheaper, faster, reliable launch services. SpaceX got guaranteed revenue and credibility to fund its next breakthroughs while proving their systems worked. Think of NASA as America's aerospace R&D department, building the scientific foundation, while SpaceX acts like the startup division that takes those breakthroughs, optimizes them ruthlessly, and turns them into sustainable businesses. So here's what we're really looking at. SpaceX didn't build this empire in isolation, and they've never claimed to. They stood on 60 years of NASA research, taxpayer-funded engineering breakthroughs, and public domain technology that cost billions to develop. But they took that foundation and did something nobody else managed. They turned experimental concepts into profitable businesses, slashed launch costs by 10 times, and built a cash-generating machine that funds humanity's path to becoming multiplanetary. The orbital refueling breakthrough isn't just another milestone. It's the keystone technology that makes everything else possible. From permanent moon bases to Mars cities to asteroid mining operations worth trillions. What makes this moment historic isn't just the technology. It's proving that the public-private partnership model actually works when executed correctly. NASA builds the scientific foundation through R&D. Private companies like SpaceX take calculated risks to commercialize it, and both sides win while pushing human capability forward faster than either could alone. Traditional aerospace giants had the same access to NASA research, the same talent pool, the same opportunities. They chose disposable rockets and cost-plus contracts. SpaceX chose relentless iteration and operational efficiency. The results speak for themselves. Does this mean private companies should abandon government partnerships entirely and go fully independent? Or is this collaboration model the only realistic path to achieving goals as ambitious as making humanity multiplanetary? Drop your thoughts in the comments below because this debate shapes the next chapter of space exploration. If this breakdown gave you a new perspective on how SpaceX actually built their dominance, smash that like button and share this with anyone fascinated by the business of space. And subscribe to Space Update 24 hours so you never miss the real stories behind the headlines. We're covering the breakthroughs that actually matter, not just the hype.